Good morning to all of you. Welcome you guys. Welcome you all. I think we are live. First of all, do comment करके बोलिए ना. Is the audio videos clear to everybody? Very good morning to all of you. So, yeah, first of all, you can see now here a great news too from Unacademy. So you can start your serious preparation with the Unacademy. So that is just 9,999 only. For this GATE 2027 का preparation, it can be happen only just 9,099 only, and use the code BARC and to avail this great opportunities. Okay, use the code BARC and to have a great learning experience from the top educators. And we started the new batches we have started. You can see now here from 13th March onwards हमने नया batch शुरू किया, and you can use the code BARC to join these batches. Right, so 13th March we have started the 2027-2028 के लिए नया batch हमने launch किया. So these are the ESC 2025 rankers from Unacademy से. And Unacademy starters kit is which is available and in all the stores. You can utilize them. And so meet your new friend Una. So here is Una, which is available in the 3 modes now: voice mode, quiz mode, smart summaries. And the test series live. So we do offer the 2 subscription. One is a plus wala, the other one is iconic. And plus में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग होगा, evaluated test series and structured courses PDF, live test and quiz and unlimited access. आइकॉनिक में इसके साथ क्या मिलेगा? इधर पर्सनल कोच भी मिलेगा, फिजिकल नोट्स मिलेगा. Right. So you can book your time slot according to your convenience and directly connect with your mentor. Let's crack it. These are the year GATE 2025 rankers you can see now. Right. And the last class we have completed some problems. We have finished it now. So we'll continue the remaining problems. Last class we did some problems. I hope all of you are getting confidence. So चलिए, so we'll continue the remaining problems. ये सारे के सारे problems हमने complete किया, complete हो गया. And the BARC paper, these questions are little twisted questions, so you need to be careful. Right. Yeah, take the next problem. In the given figure, the value of V0 is. The value of V0 is. So here, this is a ground is given now. So this means this is V0. And all these are same nodes are V0. Tell me now V0. We can write the nodal equations. V0 minus 6 by 1K plus V0 minus 4 by 1K and plus V0 minus 2 by 1K, which is equal to 0. 1K will get cancelled, so we'll get this V0. So that is 3 V0 and which is equal to 10 plus 2, 12. So that is V0, which will be equal to how much now here? 4 volts. Got it? V0, we got it as a 4 volts. Next one. In the figure shown, the current in 10 volts battery. The currents in the 10 volts battery is close to how much the current in the 10 volts battery they are asking to find. They are asking how much is current value they are asking. Right. Now you can tell me now what we can do here. So this current के लिए what we'll do here, if I call this current which is going, this is I, either some current will go, now this current I'm calling it as I1, and we can write, so then whatever this current here, tell me now, this will be given as I minus I1. So write the KVL in the two loops now. So tell me the first loop, what we can say now, this is 10 equal to, so 10 into I minus I1 plus 4 into this current, total current is I. So it will come to be a 10 equal to, what we have, tell me now, 14I minus 10I1. So let us say equation 1. So KVL in the second loop, tell me KVL in the second loop is, that is 5I1 plus 20 plus 2I1. I1, so this is minus 10 into I minus I1, which is equal to 0. So you tell me now 5 plus 2, 7. 7 plus 10. So that is 17 I1 will come. And what else we have? Minus 10I, and which is equal to what, tell me now here? Minus 20. So we have two equations and two unknowns. So we need to get the value of I, we need to get. So for this, I value we should be getting here. Here we have 14, here we have a 10 is there. If I multiply, so this equation, yeah, this is 140I, 10 say multiply, so this is, no, sorry, we should multiply with what, tell me now, this is 17. So this equation, so this is minus 10I1 plus 14I, which is equal to 10. Multiplying the second equation with 10 by 17. So this will be 10I1 minus, we are multiplying with what, tell me now here? 10 by 17 we are multiplying. So this is 100I. And this is minus 20 into what, tell me now? 10 by 17 we are multiplying. So when you add it now, will come I value. So you can see now here, I value come to be what, tell me now? 14 minus 100 by 17. Yeah, which is equal to 10 minus 200 by 17. Yeah, simplify करके बोलिए ना आंसर क्या आएगा. So LCM लेके simplify किया तो, so this is 14, थोड़ा calculations होगा ना, 100 by 17. So this value 8.1. So this is 8.11 into I, which is equal to 10 minus 200 by 17. So which will come to be a minus 1.76. So this divided by 8.11 kiya to, so you finally 0.2, like this we got 0.21. So this I value which will be a, this is minus 0.217. We got like this much. So how this flow of current, you tell me now here, 0.21. This much is the current now, tell me. So we can identify this option, kya hoga, you see this thing here. 0.21 we got I value. So from this, लेकिन but option तो नहीं match हो रहा. We are getting positive, so negative. There might be negative to positive, then this is correct. Yeah, so might be some correct. So positive negative हमने गलत किया, so एक बार check करिए. Next, the value of current I1 flowing from the A to C is A to C. A to C, the flow they are asking to find. Now you can tell me now here. So if I redraw this part of circuit, yeah, this is A and this is C. This is given B and this is D. Yeah, this values given, you can see carefully first thing. So this value 2, this is also 2. Yeah, this is 2, this is 2. And this value not mentioned also. Okay, anyway, bridge is balanced. If the bridge is balanced, then there is no flow of current now. So here, they given another one here. A to C, there is one more resistance is given. A to C. Like this, I can place now this A to C resistance. A to C resistance. How much now? 4 plus 4, this is 8 ohms. And they connected the some source A to C only they has connected, you see. And this positive, this negative. This is connected like this. And this is 8 volts. Now they ask him to find the current. So that is direct now. So then this voltage directly, this voltage is how much now? 8 volts. Then this current, here this current will flow. How much is current now? If I call this current is I1. Next we'll see this current is also then A to C. So now we can see now these two is 2, 2, it is a 4. 4 and 4 parallel will become 2. So that means how much this current now here, this current if I call this as I2. So this current I, which will be the total current delivered by the source, which I can say this as I1 plus I2, which will be equal to what will be now I1, which is equal to 1 ampere, I2 value 2 amperes. So that is total current I, which will be equal to, yes, we are getting it as 3 amperes. But no option. Check it once again. हमने कुछ गलत किया क्या इधर? So anyway, this bridge is balanced. There is no effect of this diagonal element, right? So we have removed this one here. This is 4, 4, 8 only. This is 2. So this is 4. This is 4. Will come 2. 2. Okay, 2 now. So this value. Okay. हमने गलत किया. So this value, I value, which is equal to, this is I1 plus I2. So this I value, I1 is equal to, this is 8 by 8 plus this is 8 by 2 now, equivalent. So this value is 1 plus 4, which will be equal to 5 amperes. This is how much you can see now, 5 amperes. So option D. Next one. An ideal cell of EMF 10 volts connected in the circuits on the figure. Each resistance is to the potential difference across the capacitor when it is fully charged. Yeah, first of all, capacitor DC supply. For DC, capacitor is an open circuit. Yes, for DC, and capacitor will behave like a open circuit. Now let's find out now here. The current will flows, yes, like this. Yeah, so you can see now here, this current will flows like this. Now you can see now these two R1, R2, these two all values now 4, 4 and 2, that is 4 by 3. 4 by 3 plus R equivalent will come it as what element of 4 by 3 plus 2. How much is value? 6 plus 4, 10. So that is 10 by 3 ohms. Then what will be this current value? Tell me now here. 10 by 3, which will be equal to 3 amperes. The current delivered by this source, which will be a 3 amperes. Okay. Next, thereafter, they ask the potential difference across the capacitor, this voltage for KDA. So then, yeah, we need this current be required. Okay, so that means how much this current, if I call this current is I1. So tell me this I1 value, tell me now 2 to 4, that is 4 by 6. 4 by 6 into 3. So this value 3 2's and this value I1 value, how much now here? 2 amperes. I1 value 2 amperes. This current is 2 amperes. So this current is also 2 amperes. So that means you can see now here, and again this current is 1 ampere. This current is 1 ampere. So no, 2. This is 3 amperes. So then this voltage, which is equal to 6 volts, and this voltage, which is equal to 4 volts, and so then total voltage, which is equal to 10 volts. Then voltage across capacitor, that is, which is equal to how much now? 10 volts. Got it, all of you? Tell me. Next, for the circuit shown, R1 given, R2 given, okay, E1, E2, E3 given, the potential difference between A and B is, potential difference between A and B. So we have taken this as a ground. So if I call this voltage is V, let's find this V value. Right, tell me the nodal equations now here. R1. So this is, yeah, this is 1, this also 1. Yeah, this is 2, this is 1, and this is 1. So you can tell me now what will come. So this is V minus E1. E1 is how much now? 2. 2 by 1 plus 1, which is 2, plus. So V minus E2. E2 value how much now? E2 value 4. That is 4 by 2, plus V minus E3. That is 4 by, so 1 plus 1, 2, which is equal to 0. So this we can say now 3V by 2. Or we can simply cancel the 2. I will cancel it. Okay. 2 only enough, for all will get 2. This also will get 2. Yes. So this means V. 1, 2, 3. So that is 3V, which is equal to 10. 8, 10. So that means V value is equal to what element of 10 by 3, which is equal to what element of 3.3. Yeah, this one now 3.3. This is. Next one. In the given circuit diagram, the currents I1 I4, I5 are shown in figure. They asked him to find the I2 and I3 currents. So this problem based upon the KCL. I1 value given. I1 is given downward direction. So this means I1 will go upward direction. This value, how much now? 0.3 amperes is given. Next, I4 given. Where is this I4 now? Here is I4 is given. How much now? This is 0.8 amperes. Okay. Next, I5 given. Where is the I5 value? Here. This I5 value given as a 0.4 is given. Right. So then this is I5. So this is also 0.4 only, first thing. Okay. That means I6. I6 value 0.4. Okay, so we can eliminate this option, we can eliminate. Next, thereafter, here, so you can see now this current. So this I3, how much is I3 value, which is equal to 0.4 amperes. Okay, this is 0.4 amperes. Now, what about this I2 value? Tell me, this I2 value, that is 0.5. 0.5 amperes now. I2 value. No, I2 value, how much now here? This value. So this is 0.8 going and this is also going. So this value 1.1 ampere. 1.1 amperes. So you can see now here I2 value 1.1. Next, I3 value 0.4. Yes, 0.4. Option B. Next, I6 value we got. I6 is also 0.4. Option B. Next, in the circuit shown, the potential difference between A and B is. Yeah, we can use the source transformation technique. Source transformation if I use now. Right, so then here this resistance, which value, and this value which is A, and how much this value, tell me now, this is 5. Now you can convert now source transformation method. If I convert this as a current source, how much this current is? A 1 ampere. Current is 1 ampere. This current direction is left side now, and this is 1 ohm. Next, this one, this current is 2 amperes and direction is left side only, 1 ampere. Next, this one is 3 amps. This is also this direction, this is 1. All are same direction, so we can combining this thing, which will come to be a, what tell me now here, that is 6 amperes will come. These three are in parallel, right? So this value will come to be a 1/3 ohms. Again, source transformation to current source, then it will come to be a 6. So voltage, which will be a 2 volts will come, and 2 volts and 1/3 will come in a series. So that means this one, this is positive, negative, and this is like this. Now this voltage is 2 volts and this is 1/3 ohms. Again, this resistance we have 10 ohms, and this point is B. Yeah, right. So now, what about this current? If there is no current open, then it is 2 volts. If no current is passing, if this current is 0, then what is this thing? VA minus VB. and which is equal to 2 volts. Next, the currents passing through the resistance R1 and R2 is if I call this is a common ground, right? So you can see now at this one the node voltage which is equal to minus 10 volts. Minus 10 volts. Then this current I1, only they are saying the magnitude only now. So this, and we'll find this current we can find. So this current I1 if I call, yeah, of course this current is upward direction. So which will be equal to what, tell me now? 0 minus 10 by 20 and which is equal to 1 by 2 amperes. Next, what is this thing? I2 value, tell me, which is equal to this value minus 10 minus 10 by 20, which will be equal to what, tell me now? Minus 1 ampere. So this I2 value 1 ampere. Okay. So this means this current is 1 ampere. Yeah, this current is 0.5. That means, no. Yeah, so then this current, yeah, correct only. So this current we have 0.5 now. 1 second. So this current we got it as what element of 0.5. Yeah, this current is 1. So then this current is 1.5 now. Okay, they are asking to find the I1 and I2. This current is 1.5 then. But they didn't asking about this current now. No issue there. They are asking about this current. So this one, current for this R1 is 0.5. Okay, where is that? And R2 is 1. But no options are there. कोई गलत किया क्या हमने, चेक करके बोलिए. Ground. So then this voltage which is equal to minus 10 volts. Okay. Now this current will go upward direction. So this current is what, tell me now, if I say this is I1 which is equal to 10 by 20 which is equal to 0.5. Next, what else you see this thing here? This is I2, this current. This is minus 10 minus okay. So this I2 value, this minus minus 10, this is plus 10 by 20 na. So this is what I'll mean now, 0. So this is minus minus. We did a mistake. Next, when the switch yes in the circuit is shown is closed, switch is closed, the value of current I is this current we need now. If I call this voltage is something Vx, let's find the Vx now. Now this is Vx minus 20 by 2 plus Vx minus 10 by 4 plus Vx minus 0 by 2 equal to 0. So we can see now Vx by 2, Vx by 2, Vx. So here we have taken Vx common. Then it is 1 plus 1 by 4. Yeah, which is equal to what? Tell me now. 10 plus this is 5 by 2. 20, 25. 25 by 2. So that is Vx into what we can say now here. 5 by 4 now. 5 by 4 equal to 25 by 2. So cancel it now here. 2 2's and 5 5's. So that means Vx is equal to how much now? 10. Vx equal to 10. So we need to get this current. Where this, which current? I. So this current we need now, this current. So this I value, which is equal to 10 by 2, which is equal to 5 amps. Next one. In the circuit shown, the current in the 1 ohm resistor is, where is 1 ohm? Here is a 1 ohm. So this current we need. So what we can do? Now, if we have taken this as a ground, we have taken, and this potential is V if I call. Yeah, you can tell me how much is V value? V plus 6 minus 0 by 3 plus V by 1 plus V minus 9 by 5 equal to 0. So that means V we have taken common, that is 1 by 3 plus 1 plus 1 by 5. Yeah, which is equal to minus 2 plus 9 by 5. So we have taken common, this is 15 is LCM, and which will come it as 5 plus 15 plus 3, and which is equal to, again 5 is LCM, this is minus 10 plus 9. So cancellations now here, 5 3's. So this value, so 20 23. So this is V into 23. Yeah, which is equal to what? Tell me now, minus 1. So that means how much we got this V value? Tell me now. So we have V is equal to minus 1 by 23. We need to get this current. So this means how much is I value? Tell me now here. V by this thing. Current will flows from Q to P. How much is value? Tell me now here. I by 1 by 23. Yeah, 1 by 23 means how much this value? Yes, that is from where to where you can see now. Q to P. So which will come to be a how much? 1 by 23. 1 by 23. How much is value? V plus 6 by 3. This is V by 1. V minus 9 by 5. Yes, correct only now. But why we are not, options are not matching? Check करो एक बार. कोई कैलकुलेशन गलत किया क्या हमने? So we have taken V common. This is 1 by 3 plus 1 plus 1 by 5. And which is equal to minus 2 plus 9 by 5. So that is V common. So 15 is LCM now. So this is 5 plus 15 plus 3. This is 23. So which value? Minus 10 plus 9 by 5. 5 threes. So V value is what? Tell me. So okay, this 3 we had in cross multiply. Minus 3 by 23. Yeah. Here we did the mistake now. The 3 is a mistake. So this is 3 by 23. Now check this thing here. So 0.13 from where to where? Q to P. Next one. The ratio of heat dissipated per second through the resistances 5 and 10 in the circuit is heat dissipations. So I can say this one, this voltage so same I. This power, which I can say this as what I don't know, V square by R we can write. Voltage same, that means P proportional to 1 by R. So that means P1 by P2, which will be equal to R2 by R1. So this value 10 by 5, which is equal to 2 by 1. Next one. An electric bulb rated 5 watts 200 volts is connected across a 100 volt source. The power dissipation is. So, what is the resistance of the bulb? You tell me now here. That is V square by P, which is equal to 200 into 200 by 50. So, this is 50 fourths now. So, this is 800 ohms. Now it is connected to 100 volt supply. So this power, which is equal to what else now? V square by R. So this is 100 into 100 by 800. So zeros will get cancelled. How much now? 4 2s, 4, 25. So which is equal to 12.5. Next one. In the following circuit, the battery has an EMF of 2 volts and an internal resistance of 2 by 3 ohms. Okay, the power consumption in the entire circuit is. So you can see now here, these two are parallel. These two parallel, 1. And these two parallel will become 1. 1, 1, series 2. So this overall value, which will come to be a what? Tell me now here, R equivalent. Yeah, which will be a 2 by 3. Yeah, 2 by 3. Yeah, 2 by 3 plus another 2 by 3, which will be equal to what? Tell me now here, 4 by 3. And they asked him to find the power consumption. So this power P is equal to what? Tell me now, V square by R. So that is, which is equal to 2 square by 4 by 3, which will be equal to 3 watts. Next, when a potential difference V is applied across a wire of resistance R, it dissipates the energy at the rate of W. If the wire is cut into 2 halves and these halves are connected mutually parallel across the same supply, the energy dissipation is. So that means I have, when a potential difference V, so this means I have this wire of resistance is R and this is connected to some battery connected, some source. Potential difference V, this resistance is R. In this case, power. So how much is power? You tell me now. That is V square by R. And if I say energy, if I say that is power into time, so that is V squared by R into T. Okay. Now what they did now here, this same wire, now they cut into two pieces. If the wire is cut into two pieces, then we have the resistance equivalent R by 2, R by 2. Now, so this means what is the equivalent resistance in this case? You tell me now. That is R by 2 parallel to again R by 2, which will come to be a what? Tell me now here, R by 4. R by 4. So tell me what will happen now, R by 4. Now this new power, if I say P dash, which will be given as again V squared by R, so it will come to be a where, so this is V squared by, that is R by 4. That means 4V squared by R. Now this P dash, which will be a equal to 4 times the initial power now. So it will be, work will becomes 4 times the energy dissipation. Next, two electric bulbs rated are connected in series. If the 25 watts 100 watt bulbs draws a power P1, P2, then they ask him to find the P1, P2 values. So let's find the resistance of each bulb. If I calculate the resistance of the first bulb is R1, which is equal to, that is 220 square by 25. Why is it given odd values? Next, what about this R2 value? Tell me now here, 220. The same supply is given here. Same supply they given. Okay. Yes, 220 into 220 by 100. Okay, so fine. Now I can write, get the relation between these two better. So that is, I can say this as R1 So this R1 I can write as 4 times of R2, tell me. Yes, then it is easy. R1 equal to 4 times of R1. So now they connected in series, they connected. This connected in series only. And so supply is given 220 only. Yeah, this is R1 and this is R2. This supply is 220. Okay, so then we can get this power voltage we can get now. So if I find this value of current I, tell me the I value, tell me now. Yes, 220 by R1 plus R2. So which will be a, that is 5 R2 will becomes, isn't it? So that means how much this value you can see now here, this is 220 by 5 into R2 value is what, tell me now, 220 into 220 by 100. So 220 will get cancelled. So the 0 will get cancelled. 5 2's will get cancelled. And this value 11. 1 by 11, isn't it? I value will come to be a 1 by 11 amperes, isn't it? Check करके बोल. I value we got it as 1 by 11. Now they ask him to find the powers. I square into R. So this power P1, which will be given as I squared into R1, which will be a I square. This is 1 by 11 into 11 into what we can see now, 220 into 220 by 25. So you can simplify now here, 11 2's 20, this also 11 20s. Okay, 5 fourths, 5 5s, 5 fourths, which will be equal to 16 watts. Next, whatever the P2 value, tell me now, I square, that is 1 by 11 into 1 by 11. R2 value, that is 220 into 220 by 100. So cancel करके बोलिए now 11 20s. 11 20 0 0 0 0. So this value is 4 watts. So this is option A. Tell me. Next. In the circuit, show the resistance small r is a variable resistance. If small r is equal to F into capital R, the heat dissipation in R is maximum, then the value of F is. The heat dissipation small r is maximum. The small r is a variable quantity. So we can use what term? MPT. MPT we can use now, maximum power transfer theorem. Indirectly they ask you to find RTH value, they ask you to find RTH value. So tell me now how much is RTH value? We need to find the equivalent resistance between these two terminals we need to get. And voltage source now, so it is shorted. And this is A and B. Tell me now here, these two parallel. This is R and R parallel. So that means what is the equivalent resistance, you tell me now, which is equal to, this is R by 2. That means small r is equal to what, tell me now, R by 2. That means F is equal to how much now? 1 by 2. MPT. Next. In a large building, there are 15 bulbs of 40 watts, 5 bulbs of 100 watts, 5 fans of 80 watts, and 1 heater of 1 kilowatts. The voltage of the mains is given as a 220 volts. The minimum capacity of the main fuse of the building is. That means indirectly they ask you to find what will be the current. Okay. So obviously how this connection will be done, all the equipment, household equipments are connected in parallel. The total current supplied by the source is sum of all the currents. Okay. Let's find out now here. There are the 15 bulbs are there, having the power is this much. So from this 15 bulbs, so this power, so how much the current in this case, bulb, for the bulbs, the power is given as what element of 40 watts they given, and supply voltage which will be a 220 volts only na? From this we can get this current. I is equal to P is equal to V into I is equal to what we'll get now here, P by V. So this means we'll come it as P by V. So how much is I value, tell me now, 40 by 220. This is the required current. Yes, for one bulb. For one bulb, this much. Next, 5 bulbs are there, this category. Okay, this is the, and 5 bulbs are this category. Okay, now let us say this is I1. Now we'll find this I2 value. How much now? This is 220 by 100. No, sorry, this is 100 by 220 now. 100 by 220. Okay. Next, what about this I3 value? Heater fans, 5 fans are there, so this is 80 by 220. Next, we can say I4, how much now here? 1 kilowatt, that is 1000 by 220. So that means the total current, so that should be given as what I can say now here. So I1 plus I2 plus I3 plus I4. So this is I1, which is 15 bulbs are there. We can say 15 into I1, that is 40 by 220. Plus these are 5 bulbs, 5 into 100 by 220. Next, I3 value, that is what element of 5 into, that is 80 by 220. Next, another one is what element of 1000 by 220. Here simplify करके बोलिए ना what will come the total current. So yeah, 120 is the LCM na. So 60, 600 plus this is 400 plus 40 plus 1000. Yeah, tell me how much now? 2000, 2500 na? Yeah, 2500 by 220. So simplify karo, how much will come? 0, 0. 211 to 125. So how much this value? 125 by 11. So this is 11.36. So that means minimum capacity. We got it as 11.36. Now this is the minimum. So what should be? We should go for now here. 12 should be required. Minimum fuse capacity must be 12. Done. Next one. 4 bulbs are given like this, are connected to the mains. Okay, as shown. They ask you to find what the reading in the ideal ammeter is. Okay, this reading means only the B2, B3, B4 current will come. So they given this watts. We can get this current, we can get. So this current reading of ammeter reading. Yeah, ammeter reading, which will be equal to, so this is I2, this is I2, this is I3, and this is I4 only will come. I3 and this is I4. So you can tell me now this I value, I2 value, all are same only, na? Identical bulbs. Same supply. So means we can say 3 into I2 I can say. So this is I is equal 3 into I2 value. So this is I is equal to V P by I. P value 100. 100 by 220. 0, 0. So this I value which will come it as 30 by 22. So 1 point something, 1.35 maybe. 30 by 22. 1.36. Yes, so this value 1.36 amperes. This could be the option. Next, two electric bulbs rated like this are connected in series to a supply. Which bulb will fuse? So if I call this bulb is R1, this bulb is R2. Here you can tell me now this R1, which is equal to V square by R. So this is 220 into 220 by 25. How much will come? You can see now here 5 5s, 5 4 20, 5 fourths. Again 5 fourths, 5 fourths. So this value R1, which will come to be a, so this is 44 square now. So this value 44 into 44. So 1936. And what about this R2 value? So this is 220 into 220 by 100. So that is R2 value 22 square. So which will come, this is 484. Okay. Now what they did now here, these two are connected in series to a supply. These two are connected in series. Yeah, this is R1 and this is given R2 to a supply. How much the supply they given? 440 they given. Yeah, so they asked them to find which bulb, which one will fuse. And we need to see whichever will have the more power, then that will fuse. Now, so what will be the current now? Tell me now here. 440 by R1 plus R2. So this is 1936 plus 484. So how much is value of current? Tell me. 440 by 1936 plus 484. This is 2 by 11. Current is 2 by 11. Okay. How we'll find this power now here? So power across first one, which will be I square into R. So this value 2 by 11 whole square into R. R1. R1 is we can write 44 into 44 I can write. So this P1, which will be a 4 by 11 into 11 into 44 into 44. So this value cancellation. So 11 fourths here, 11 fourths here. So here 16, 64. 64 watts. Okay, first one will goes out. And second power also we can calculate now P2. Yes, 2 by 11 whole square into what element now? This is R2. R2 is what element? 22 into 22. Okay, so this P2 equal to what element now? 4 into 11 2s. That is 4. 1 second. This value is what element of 4 by 11 into 22 into 22. So in this value 2, this value also 2. So this P2 is equal to 4 into 4, 16 watts. Yeah, this is safe only. Only this will go sour. This will get damaged. Next, an electric bulb is rated this much. The power consumed by it is when it is operated 110 volts. So first of all, we can find this R is equal to, this is 220 into 220 by P. So this is 100. So this R value is what we can say now, 22 into 22 ohms. Okay, next, when it is operated this much, now, so power we have now P is equal to V square by R. So this P, that is 110 into 110 by R. R value 22 into 22. So you can see this thing here, 11 tens, na 11 twos. Okay, this is fives. So this also fives only. 5, 5, 25. So this is 25 marks. Next, a heater coil is cut into two equal parts and only one part is now used in the heater. The heat generated is. So as when you cut it now here, so this power P equal to what will be now? V square by R. Two equal parts, voltage को same है. So power P proportional to what will be now? 1 by R. The heat generated, so then what happens? So initially the resistance which we have a R, okay, two equal parts. Now this R2 equal to what else now? R by 2 only. The resistance is R, power P2 will becomes what else now? 2P banega na. So that means double, isn't it? So that means it will become double. Actually, we have the resistance of a hot tungsten filament is about 10 times the cold resistance. Okay, what will be the resistance of 100 watts and when not used? Okay, when not used. Okay, when it is used, tell me now here, this is when it is used, how much is resistance, you tell me now. V square by R, so this is 200 into 200 by 100. So this value will come to be what else now? 400 ohms. And so this is a hot. Now we need cold now. Cold is what else now? 40. Next, time taken by a 836 watt heater to heat 1 liter of water from 10 degrees to 40 degrees. Fine. Okay, that's it for today. We'll continue next class.